Good morning, calc fans. How we doing on this fine Thursday morning? It's a beautiful sunny day outside out there. It's supposed to get warmer throughout the day and also nice the next couple days. So go out and enjoy some of the nice weather and get some fresh air. After the last few days, we all need that a little bit. Need a little bit of vitamin D. That would be good. I hope all is going well with your family. I hope everything's okay at your house. Everybody's staying ill-free. Once again, continue to remember, practice your social distancing out there. Everybody needs to do their part. Tomorrow we will have a quiz. We will have, chapter 4 test. I will post it tomorrow morning. You need to get it done by tomorrow evening. We're going to go through one of the problems from the in-class assignment, or not the in-class assignment, but the review sheet I posted yesterday. I'm not sure which one it is. It's one at the bottom of the first page. It would be problem number, it's marked as 2 in the bottom, but really it's 3, 4, 5, 6. So it's one at the bottom of the front page. We want to be able to calculate the limit as x approaches 0 of x cubed over the sine of x. Okay, once again, as we talked about trig functions, taking the limits, the first thing we always try to do is we try to plug it in. Okay, but if we plug it in, we get 0 cubed over 0 minus 0, which is 0 over 0, which is an indeterminate form. So what we have to do is we have to be able to find our limits. Well, this is not a factorable thing, so we have to find another way of being able to calculate the limits. That's where L'Hopital's rule comes in, which we also tagged as Bernoulli's rule, okay, because Bernoulli was the father of this. He was the founder of this, but L'Hopital paid his money to be able to put his naming rights. Okay, we talk about naming rights, stadiums and all the stuff. People want naming rights to stadium. They want to pay money. That started back in the old age in the math world of naming rights to a mathematical process. So we're going to use L'Hopital's rule, which tells us limit as x approaches a of f of x over f g of x will equal the limit as x approaches a of the derivatives of top and bottom. And we can continue dealing with derivatives as long as we want, just continue to take the derivatives. Now, some of the confusion that happened when we took the quiz over this is we tried to use our quotient rule. We do not need to use our quotient rule on this. We just have to take the derivative of our top function and the derivative of our bottom function, so we do not have to use our chain rule. We don't have to use our quotient rule. We can just take the derivative of the top and the derivative of the bottom. Well, the derivative of the top is 3x squared. The derivative of the bottom is 1 minus, now the derivative of sine is cosine of x. So we have 3x squared over 1 minus cosine of x. But if I substitute this in, we get 3 times 0 over 1 minus the cosine of 0, which is 1. So we're left with 0 over 0 still, which is still an indeterminate form. So what do? Well, we can continue to take our derivatives. So we take the next derivative. Limit as x approaches 0 of 6x over, well, the derivative of the bottom is 0 minus the derivative of cosine, which is negative sine of x. So we're left with limit as x approaches 0 of 6x over sine of x. So let's plug the value of 0 in again, which means I'm going to put a 0 in here and a 0 in here. Well, 6 times 0 still gives me a value of 0. Well, if I take the sine of 0 in my calculator, we still get 0. Still an indeterminate form. So, if it's still an indeterminate form, we can continue with our derivatives using L'Hopital's rule. we have the derivative of 6x, which is a value of 6. The derivative of sine goes back to cosine again. So if we take a look, the derivative, we take our limit and we plug it in, we have 6 over the cosine of 0. Well, the cosine of 0 is a value of 1, so we have 6 over 1, or a value of 6. Woohoo! We finally got there. But we had to take 1, 2, 3 derivatives to be able to get to that point. But we can continue to do it with our derivatives. We don't have to use a quotient rule. We have to just keep on taking the derivatives at the top and derivatives at the bottom. Eventually we get to that point, and we eventually get to a point where we can find a value. Hopefully that helps us out with regards to preparation for the quiz. Once again, if we are the test, if we are an X, and this also goes for Newton's method, when we're dealing with Newton's method, if we have a trig function there, we need to make sure we are in a radian mode. We need to make sure we're dealing with radians, both out with this and also with Newton's method, to be able to solve values or for zeros in the Newton's method. If you have any other questions, I'll continue to check my emails throughout the day. Oh, don't want that. We'll go back to this. I will continue to check my emails throughout the day and check for any comments throughout the day. So if you have any questions on any of the problems from the review sheet, please post them or please send me a message. I will get back to you and try to help you through any of the problems. I posted the solution, so hopefully that will help us out also. But other than that, I have nothing else for us. This will be the last of what we do. This will finish out and take us to spring break. So we have nothing next week. We'll start back up on the 13th with chapter 5, which is all antiderivatives and integrals, and the meaning of the antiderivatives and integrals, and we'll go through that process of chapter 5, and that will be the last of our chapters. That should take us probably to about the first week of May. And from that point, from the first week of May on, we will look at prepping for a final in this class. So we'll just go over review material from the final. Chapter 5 will be the last we have to do. And like I said, it should take, maybe 3 weeks, possibly a 4th week. But most of the time it takes about 3.5 weeks to get through chapter 5. It's not as long of a chapter. It's not chapter 3. So I hope everything is going well once again with you. Continue your social practicing. Enjoy your spring break. We have nothing here for you. Enjoy your spring break. And once again, if you have any questions, feel free to post any questions. I tried to have a little bit of fun yesterday. Me being an old man, try to have a little fun with Google Classroom. If you've downloaded any movies that you've liked, that you would like to recommend to your classmates, go ahead and do that. Okay, go ahead and do that. I found 2 of them. The Peanut Butter Falcon was a good movie, and also Knives Out was a good movie. There's a couple harsh words in there, so you need to make sure if harsh words are not with respect to younger kids in the family, it's not you or is not you, may not want to watch it. A couple harsh words in there. Other than that, enjoy your spring break. Prepare for the chapter test. FaceTime somebody today. If you want to sit down, FaceTime somebody and work through some problems together. That's a good thing. It's a good way of being able to do some social interaction. Once again, we come to school. Yes, we come to school to get an education, but we also come to school because we like to be social. That's the human race. We like to be social. Okay, and we are missing out on that aspect right now. So, being able to sit there with a FaceTime of somebody, being able to work through problems on FaceTime together, that would be a way of being able to adjust to what we have at this point. This is what our reality is right now. We have to be open in regards to how we deal with things. You know what, I'm an old man. I've been able to post YouTube videos and be able to adjust my teaching aspect. You'll be fine. You'll be fine. You can do this. I have full faith that you students can do what we're asking you to do here. It will be okay. Once again, if an old man can do this, you can do this also. So please prep for your final or prep for the chapter test. If you have any questions, please post them. I will get back to you as quickly as I can get back to you. I'm gonna go out and enjoy some sunshine and cut some wood today. So you folks have a good day. Adios.